Good day everyone. Today we are going to begin a very interesting topic and we're talking about statistic. Are you wondering how we use statistic? In a fun side, I know you are fond of watching Netflix. Netflix uses statistic to predict what show we might want to watch. On the daily basis, we use statistic to look at the weather forecast and decide what to wear. Now let's define statistic. Statistic is the branch of mathematics that deals with the collection, organization, presentation, analysis, and interpretation of numerical data. Since research yields such quantitative data, statistic is a basic tool of measurement, evaluation and research. Uses of statistic. In a more wide application of statistic, it is used in different fields such as astronomy, business, education, science and many more. In the business, to show the quality of the product, just like the claim of Safeguard soap, the company advertises their soap that kill 99.9% of germs. Let's proceed to the two types of statistic. 1. Descriptive statistics. Concerned with gathering, classification, summary calculations, graphs, charts, and tables. The summarizing values commonly used in descriptive statistics are the measures of central tendency, variability, and of skewness and kurtosis. 1. Descriptive statistics. The totality of methods and treatment employed in the collection, description, and analysis of numerical data. The purpose of a descriptive statistic is to tell something about the particular group of observation. 2. Inferential statistic. Inferential statistics is the logical process from sample analysis to a generalization or conclusion about a population. It is also called statistical inference or inductive statistics, a method used to generalize from a sample to a population. Topics included in inferential statistics. Population is the collection of all possible observations of a specified characteristic of interest. Sample is a subset of the population. The example of population and sample. As you can see, the population is the entire group that you want to draw conclusions about, while the sample is the specific group that you will collect data. Example of population and sample. Parameter is a numerical index describing a characteristic of a population. Statistic is a numerical index describing a characteristic of a sample. Constant is a characteristic of objects, people, or events that does not vary. For example, the temperature at which water boils, 100 degrees Celsius. Variable, a variable is an item of interest that can take on many different numerical values. Example. 1. Weight of people, quantity. 2. Hair color of people, quality. Let's move on to the two types of variables or data. 1. Qualitative or categorical variables are non-measurable characteristics that cannot assume a numerical value but can be classified into two or more categories. Examples. 1. Gender. 2. Religion. 1. Dichotomous variable, can take only two values. 2. Trichotomous variable, can take three possible values. Quantitative or numerical variables are those quantities that can be counted with your bare hands, can be measured with the use of some measuring devices, or can be calculated with the use of mathematical formula. Examples. 1. Checking account. 2. Number of children in a family. Two types of quantitative variables. 1. Discrete variables consist of variates, actual values, usually obtained by counting. Examples. 1. Number of students in statistics class. 2. Number of subjects a student can enroll. 3. Number of vehicular accidents from selected places. 2. Continuous variables. Obtain measurements, usually with the units and by evaluating values using a formula. Examples. 1. Height in meters. 2. Weight in kilograms. 3. Time in minutes. 4. Final grades. Now, the collection of data. Data is the core of statistics. Without data, there would be no statistical analysis. All statistics are derived from data that are based on observations, including observations that are made directly by people to data gathered in formal research. I prepared some examples to clearly recognize the difference of discrete and continuous data. 1. The heaviest package received last week was 10.7 kilos. Continuous variables. It is continuous variable because the 10.7 kilos is measured. 2. Only 3,205 applicants passed the engineering exam. It is continuous variable because the 3,205 is counted. To understand more, this is the summary of the types of the variable. Data refers to the kind of information researchers obtain on the subjects of their research. Can be classified according to source and to form. There are two types of data. 1. Primary data. Refer to information which are gathered directly from an original source. Examples. 1. Observation. 2. Interview. 3. Questionnaire. 2. Secondary data. Refer to information which are taken from published or unpublished data which were previously gathered by other individual or agencies. Data which are already available. Example. 1. Statistical book. 2. Published books. 3. Newspapers. 4. Journals. 5. Book. Methods of collecting primary data. 1. The direct or interview method. A method of person-to-person exchange between the interviewer and the interviewee. The interview method provides consistent and more precise information since clarification may be given by the interviewee. 2. Questionnaire. Written responses are given to prepared questions. A questionnaire is a list of questions which are intended to elicit answers to the problems of a study. The subject responds to the questions by writing or marking an answer sheet. Can be mailed or given to a large numbers of people at the same time. Registration method. The method or gathering information is governed by laws. Four. The observation method. In this method, the investigator observes the behavior of persons or organizations and their outcomes. Experiment methods. Used to determine the cause and effect relationship of certain phenomena under controlled conditions. Usually employed by scientific researcher. There are 4 scales of measurement. One. Nominal data. Classifies objects or people's responses so that all those in a single category are equal with respect to some attributes, and then each category is coded categorically. Two. Ordinal scale. One which data are not only classified but also ordered in some way, high to low or least to most. It is used in ranking. It is somewhat stronger form of measurement, because an observed value classified into one category is said to possess more of a property being scaled than does an observed value classified into another category. That is, The ordering implies only which category is greater or lesser, not how much greater or lesser. Ordinal data are discrete variables. Interval scale. When the numbers used to identify observations represent not only ordering of observations but also meaningful information regarding degree of difference or distance between observation. Example. The grades of 3 students are 90%, 70%, 60%, they may be ranked 1 to 3. The difference between rank 1 and rank 2 is 20%, between 2 and 3 is 10%, the difference between 1 and 3 is 30%. Ratio scale is similar to the interval scale, only it has an actual or true 0 point which indicates a total absence of property being measured. With an absolute value point, it can be said that the ratio of two observation is twice as fast, half as long, or other. Either discrete or continuous variables. Examples include business data, such as cost, revenue and profit, and others such as weights, time, height, rate of change in production and return on investments. The summary of levels of measurement.